Find the key features of the parabola below. A grid is provided if you would like to graph the parabola, but you do not need to do so. So I notice that this is in vertex form. So I know that h is -2 and k is -3. So my vertex is going to be at -2, -3. I'm just going to go ahead and draw some axes right here. I know that my vertex will be right here. And then I know that the line of symmetry will be at x equals -2, since it's the same as the x coordinate of the vertex. And then to find my x-intercepts, I'm going to plug in 0 for y. I'll add 3 to both sides. So I get 3 equals x plus 2 squared. And then take the square root of both sides. I'll use my calculator to find the square root of 3, which is 1.73. I'll just round that to 1.7. So now we get positive 1.7 equals x plus 2 and negative 1.7 equals x plus 2. So x equals -0.3 or x equals -3.7. So my x-intercepts are -3.7, 0 and -0.3, 0. So let's see, -0.3 would be right here. -3.7, 1, 2, 3.7 is right there. And then to find the y-intercept, we plug in 0 for x. So we get 4 minus 3, we get y equals 1. So the y-intercept is at 0, 1, which is right there. And the symmetry point would be right there. We've got 3 points. We can graph our parabola, or 5 points, I mean. And there's our parabola. Find the equation of each of the following lines. You may use the grid provided, but you do not necessarily need to graph the lines. So in case we want to graph them, I'll go ahead and put some axes right here. So this line has a slope of 2 and it passes through the point 10, 17. Well, I'm not even going to have that point on my grid right here. So I need to find the y-intercept. I know y equals mx plus b. I know the slope is 2, so I know y equals 2x plus b. I need to find the y-intercept b. I do know a point on the line, x and y, so I'm going to plug that in. 17 for y equals 2 times 10 for x plus b. So we get b equals -3. So that tells me that the y-intercept is -3, so the equation of this line is y equals 2x minus 3. This line passes through the points 1, -4, and -2, 5. I can graph those. 1, -4, and 2, -2, 5. So the line goes like this. It's going down, so I know it's going to have a negative slope. And then I'll draw the slope triangle right here. And let's see, I count 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we go down 9 and over 1, 2, 3. So we know that the slope is going to be -9 over 3, which is -3. And I'm not really sure about the y-intercept right now, so I'll do the same thing. It looks like it passes through -1, but I'm not positive. So I could check on the graph by going over 1 and down 3, over 1, down 3. So yeah, it does pass exactly through -1 right there. So we know the equation of the line will be y equals negative 3x minus 1. Here we've got a table, so we could plot these points. Negative 6, negative 6. Negative 3, negative 4. 0, negative 2. 3, 0. And 6, 2. So the line's going like this. We know that when x is 0, y is negative 2. So that's our y-intercept. And we could find the slope by drawing a slope triangle. We go over 3 and up 2. So the slope is 2/3 x. The y-intercept is negative 2. We could also find the slope just by looking at the table. So if we look, the y's are changing by plus 2 each time. The x's are changing by plus 3. So the change in y over the change in x is 2 over 3, which is the same as the slope. Which of the following lines are parallel to y equals negative 2/3 x plus 5? You must provide mathematical justification for your answer choices. Remember that parallel lines have the same slope. So I need to find the slope of each of these lines. I'm going to do that by putting them into y equals mx plus b form. So I'll subtract 2x from both sides, and I get negative 3y equals 6 minus 2x. Divide by negative 3 on both sides. Negative 2 divided by negative 3 is 2/3 x. 6 divided by negative 3 is negative 2. So 2/3 is not the same as negative 2/3. So this line is not our choice. Here again, we'll divide by 3 and get y equals negative 2/3 plus 6 divided by 3 is 2. Negative 2/3, negative 2/3, yep, that's going to be parallel. Again, we'll subtract 2x from both sides, and we get 3y equals negative 2x plus 9 divided by 3. Y equals negative 2/3 x plus 3. Negative 2/3, negative 2/3, yep. And the last one, we'll subtract 3x from both sides. We get 2y equals negative 3x plus 6, divide by 2 on both sides. Y equals negative 3/2 x plus 3. 3/2 is not the same as 2/3. Not that one. Graph the parabola on the grid provided. You must have at least 5 points graphed. So let's see, I know that because this is negative, my parabola is going to go down. So I can tell that right away. First, I'm going to use the zero product property to find my x-intercepts. So I'm going to plug in 0 for y. So we get x plus 1 equals 0, x plus 5 equals 0. So x equals negative 1 or negative 5. So the x-intercepts are negative 1, 2, 3, 4, negative 5. That means that the line of symmetry is going to be right here in the middle at x equals 3. I know the vertex is going to be somewhere up here at x equals 3. So I'll plug in 3 for x to find the y coordinate. Four times 8 is 32. So I got that my vertex should be at, oh, I see my problem. This should be a -3, -3. So this should be -2, and this should be 2. -2 times 2 is -4, and then -4 with a negative is +4. So the vertex should be at -3, 4. And then the last point that I'll find is the Y-intercept. So I'll plug in 0 for x. So y equals -1 times 5. Y equals -5. So the Y-intercept is -5, and I can put the symmetry point right here. And now we've got a parabola. For the following equations, name the type of function and the transformations done to the parent function. So the type of function here is an absolute value. I know that because it has the bars. The transformations, well, we've got an A, and it's negative, so we know it will be flipped. We know that it will be stretched by a factor of 4. And this is H, so we know that it will be shifted horizontally to the right 3. And then plus K is really plus 0, so there's no vertical shift. This function right here is exponential. I know that because it has 2 to the x. It has x in the exponent. And I see the -1 right here. That's our k value. So the only transformation on this function is a vertical shift down 1.